2 and f of 2. If they are not equal, you will have to say Rolle's theorem is not applicable. But if all three conditions or hypotheses are fulfilled, then you can say, therefore, by Rolle's theorem, there must be a number between this and this open interval such that f prime of c is 0, because it has to have a term. So we differentiate. We replace x by c. We set it equal to 0. You can definitely apply the apps for finding the solutions. It's fine, perfect. And I found two solutions, one of them negative 2/3, which is in the interval, but the other one is 2. You can say, but 2 is not in the open interval. So C cannot be at the endpoints. So that's the Rolle's theorem. And the mean value theorem has only the first two conditions. You have to find f prime and then f prime of c, and you have to equal that to y2 minus y1 over x2 minus x1. And do not forget, you have to write that this number belongs to, you don't have to use the symbol, but you have to say negative 2/3 is in the interval open negative 2, 2, like here. It happens that both solutions, we have two C's. We have the positive the square root of 4/3 and the negative the square root of 4/3, and both of them I checked, both of them are guaranteed to be between negative 2 and 2. So now we can go back to 4.2 and we can choose a problem. Any problem you want, let me know. So these are all posted. So this is in 4.2. Okay, so we're ready. So these are the problems we're looking at. You can choose any for Rolle's theorem. And then for the intermediate value theorem, the mean value theorem, these. You choose. One other thing that I was going to say and I forgot is you should always check after you graph. You should always check your graph. And don't forget, you have to, the slant asymptote or the horizontal asymptote has to be entered separately. So when you enter x to the third and divide that by x minus 1 squared, now we know the graph. We already graphed everything. We have to choose the correct viewing window. So x minimum negative 10, because I have the graph in front of me, right? Negative 10, maybe negative 7 will be good enough. X maximum, 5 will be good enough. Maybe 6 will be good enough. We can always go back and adjust. But negative 10 is not good enough, or maybe not. No, that was negative 8. Yeah, it's okay. But I would like to go to negative 16. Too far high up in the positive? No, not really. I think that 6 would be good enough because I already know the graph. And now I click on graph. So this is terrible. I entered something else. What did I do? Or why is this going up like that? That's what was the was x minus 2? What's going on here? What did I enter? Ah, of course, I got it. Good. Yes, more like it. Yes. So the vertical asymptote is at -1. We see the maximum, and the graph approaches the asymptotes asymptotically, we say. So there is a piece of opening down, and then the inflection point, and then opens up, going asymptotically closer and closer to the asymptote. You should always check, but be sure that you enter the function correctly. Okay, sorry about that. Good, so back to the book. You choose. Do we still want to look at mean value theorem or Rawls theorem, or not? Anyone with me, please?
I'm good with Rawls theorem. I'm struggling on another problem, but I didn't
Yes.
want to interrupt you.
I'm ready.
Okay, so it's the limit as x approaches infinity for x sine 3 pi over x.
So make sure that I copied this correctly. So it's x multiplied by sine, and sine is applied to 3 pi over x.
Correct.
Okay, perfect. Awesome. And when x approaches infinity.
Yes. So I plugged in infinity, and I got infinity times 0.
Yes. So when x approaches infinity, this approaches 0, sine 0 is 0, and this is infinity. Excellent. So all you need to do now is just a simple manipulation, algebraic manipulation. This is not a bad one. So limit as x approaches infinity, and we have sine 3 pi over x, everything divided by 1 over x. Because dividing by 1 over x is like multiplying by x.
Right, okay.
So now we do have 0 over 0, because 1 over infinity goes to 0 and sine still goes to 0. But then we have limit x approaches infinity. Now careful with this. When we differentiate it, we should know this by now. This is very important, a very important formula. And when I differentiate that, I do have cosine 3 pi over x, but times the inner function prime. And I have to be careful, because the inner function prime will be 3 pi over negative x, or negative 3 pi over x squared, I meant to say, and I didn't.
Times negative 3 pi over x squared.
Right, because we differentiate 1 over x, which is negative 1 over x squared, and the 3 pi has to stay.
Okay.
Now, this is really nice, because when x approaches infinity, this approaches 0, but this approaches 1. Brilliant. But we have to notice something extremely important now. The negative 1 over x squared at the top with a negative 1 over x squared in the denominator will go away.
Yeah.
So what is left is just 3 pi at the top. Negative 1 over x squared with negative 1 over x squared, and 3 pi is left. So the answer is 3 pi. Very nice. It's a very nice problem.
Yeah, I was struggling to differentiate the inner function. I was blanking.
Yes, so when we differentiate 3 pi over x, we say 3 pi times 1 over x prime, which is negative 3 pi over x squared.
That makes sense.
So always when you see a number over x, always think in terms of 4 times 1 over x.
And then just differentiate them.
And that's so much easier to differentiate. You don't have to worry about 4. That makes it easier, yes. Very good. Other questions? I did post a node test. I don't know if you looked at it yet with solutions. Other questions for me? Anything? Aaron, do we still need to go through Rawls or mean value theorem?
Nope. I think good on that.
Okay. Now, one thing I was going to talk about, and then I'll let you go unless you have questions for me. Remember when a rational function or a function has a hole in the graph, like for example, x plus 1 divided by x squared minus 1. Well, I have to find the domain. So in order to find the domain, I have to factor the denominator. The domain is still all real numbers except plus or minus 1. And now I can simplify after I state the restrictions, not before. So x equals -1 becomes a whole because the factor disappeared. But x equals 1 stays, so that must be a vertical asymptote. If the factor stays, it's a vertical asymptote. If that factor goes away, the function is still undefined there. How do I determine the y value for that? Just plug it in. -1 over -2. So it's -1 and 1/2. That will be the point that is the hole in the graph. Or
can you say that part again? If the factor stays?
If the factor stays, it's a vertical asymptote. There is nothing I can do to it. But if the factor goes away, the function is still undefined there. So that makes it a removable discontinuity, makes it a hole.
Thank you.
How do I get the hole, the y value of the hole? I plug it in the simplified form. -1 at the top, -2. -1 over -2 is 1/2. So the function will do this at this point. Anything else? Everyone should do very well. Please do not forget by Sunday, all WebAssign from 4.1 through 4.8 with a minimum of 70%, please. Each, please. Please, I'm begging everyone.